So, as I already told, that the physical phenomena they are the major backbone of engineering, and specifically talking about CFD, physical phenomena are like much more important than any other field of engineering in CFD. So, understanding the physical phenomena means understanding the fluid flow in any cases, as I told earlier, in any cases, in the sense either artificial fluid flow or natural fluid flow. So we have to first understand how the fluid flow is going. So how the fluid flow is going, what all variation can we see, what is the resultant of those variation, what is the relationship between those variations, those parameters. So for understanding those things, there are different methods. Among them, CFD is one of them. So one of the basic method, and which many of us perform, is experimental methods. Suppose we want to see the performance of an IC engine, see the flow of air in fuel inside the IC engine, how the variation of fluid flow, airflow concentration, variation of airflow concentration governs the efficiency of IC engine, and how the variation of temperature is taken care of. If we want to do such type of experiment, then we will do the experiment in IC engine test rig. We will make the experimental setup, we will power the fuel, we will run the engine, we will take the data, and our experiment is over. We will finally calculate the unknown parameters, we will finally conclude to the final result. So this is one of the technique. Within the experimental method, if you are interested in the purely fluid flow, means pure air flow over the airfoil, flow of air past a cylinder, flow of air past a car, that I show, and this one that I have already shown, like this flow. If you want to do this type of experiment, then we can do the experiment in wind tunnel. So these are experimental methods of analyzing the physical phenomena. Next method is theoretical method. It is also called analytical method. Without doing any experiment, also we can find the variation of parameters and the relationship between those governing parameters. We can end with the good conclusion, with the final conclusion and the result we can end up without even touching any experimental setup. So that is the theoretical method. Within this, we will be solving the continuity equation, momentum equation like Navier-Stokes equation or Rayleigh equation or Bernoulli equation, and the energy equation, first law of thermodynamics, second law of thermodynamics. Those type of things we will be solving, and will arrive to the final conclusion. So that method is theoretical method. So what's next? Next is CFD. It is a numerical method. So basically these three are the major three different branches. We can call them as different branches of the approaches to solve the problems in engineering. So basically here we are going to differentiate between these two and CFD. So CFD is different than these two, and nowadays of course it is more preferable. CFD we can do the analysis within the computer. In a computer we build the model, we build the CAD model by using some CAD modeling software like CATIA or SolidWorks, and then we'll import that to some analysis software like ANSYS or SolidWorks or TechPlot, and we'll formulate the problem. Obviously we'll be using theoretical knowledge for this thing. We'll formulate the problem, we'll do the proper coding using different compiler like C++ or Java or something, and based on the combined effect of this coding and as well as the modeling, will finally conclude to the final result. So that numerical aspect, that is yet to be explained in details, but at this point of time we'll just consider that CFD is a numerical method of solving the physical phenomena, solving the engineering problems, and this is different than theoretical method or experimental method. At this point of time, we'll just say this much. So that is CFD. So let's take an example. This is a simple truss. This thing is nothing to do with CFD. I have just given this simple truss with the force applied at point B and point C. Point this D is hinged. A is having the roller support, and we are supposed to calculate the force and stress and strain. So this is simple type of thing. We can just do the moment balance along x and y axis, force balance along x and y axis, and we can finally arrive to the accurate answer, final result. This is nothing. This is nothing to do with CFD, nothing to do with any computation, nothing to do with numerical. It is purely analytical method. So what if this same problem is something like this? This is a big tall building made of lit trusses. So generally this type of problem we don't prefer the similar type of method. Here the role of CFD come into picture. Not exactly CFD, some role of some computation method comes into picture. CFD is computational fluid dynamics. So here we are not doing the fluid dynamics, we are doing some structural problem. So computational structural thing will come. So that we call as finite element method, or that could be something else also. So anyway, this is a computation. I have shown these two figure just to differentiate the idea regarding the analytical method and computational method. Both of these figure they have nothing to do with CFD. Only thing is computational. Difference between analytical method, this thing, and computational method, this. And next, this IC engine. We know that IC engine, petrol is used by petrol and gasoline. It is used, and Otto cycle is followed, or in diesel engine, diesel is used. So we know the efficiency of those things, we know the output power of those things. We have got different formulas for that. What if the fuel is changed? Instead of diesel and petrol, we use some other fuel like ethyl alcohol or methyl alcohol, or maybe some other different type of fuels. There are a number of such fuels. So what if we use such type of fuels? So will the formula still remain the valid? No, of course not. So how to get the efficiency of that engine running with some other fuel, or let's say same petrol or same diesel having different density? So what will be the final answer, final solution for the efficiency, final solution for the output power? What if the density is changed? What if the composition of petrol is changed? They are the hydrocarbons, so hydrocarbons mixture of different hydrocarbons. So what if the composition of those hydrocarbons are changed? So these things, as I told earlier, either we have to go for this experimental method, we have to build a different setup of that engine, we have to bring that fuel, that modified fuel, modified with modified density, or modified the composition of hydrocarbon, or totally different fuel. We have to power those fuel, we have to do the experiment and take the data. Either that thing, or theoretical method. Theoretical method, we have to do using different equations. Sometimes we may arrive to the situation like we will be having many variables and less number of equations. So generally for solving the linear equation, let's say for 5 variables we need 5 equations, 10 variables we need 10 equations. Sometimes we arrive to the situation like we will be having only 6 equations and we are left with 10 variables. So that is unbound type of system, unbound. We don't have fixed solution for that. So that is at that point of time, theoretical method is broken. And experimental method we don't prefer because of the expenses that we have to invest for the setup. We have to be careful for experimentation. There may be some risks of experimentation, and there are many other issues. So